accommodation is about distance. There's another important process in eye functioning that you need to know, and that is the pupillary mechanism. And Colin will explain to you what, why, where, and when.
Right, first of all, what is pupillary mechanism? It is the amount of light that enters the eye. Remember, when they ask you the function of the pupil has no other function, and I'm emphasizing this. The pupil has no other function as to allow light into the eye. But the size of the pupil,
is a hole.
Yes, it's a hole. But the size of the pupil, here you can see is small, and here you can see it's much bigger. That is controlled by the muscles within your iris, the part that gives the color to the eye. So in the iris we have two sets of muscles, but very important, pupillary mechanism is there to protect the retina against too much light that enters the eye. And there we have it. And I think it's very good actually to show them on the whiteboard how it happens. I'm quickly going to run through this. So what happens in bright light and what happens in dim light? You can actually take a friend of yours and ask someone to switch on the light. Look at the size of the pupil and look what happens in bright light. And what causes this smaller pupil is because, and I also like doing this, showing them that this is your circular muscles within your iris. So if they contract, can you see what happens to the hole? Becomes smaller. And the circular muscles, that works antagonistically with your radial muscles, which means if they contract, the radial muscles relax and the pupil becomes smaller. And exactly the opposite happens in dim light, where the radial muscles again, they contract, and when they contract, your circular muscles, they will relax and your pupil opening becomes bigger and allows more light to enter the eye.
Now, just one or two questions. Shante has asked what's the problem if you're able to see close by and distant. Then Shante, your eye is accommodating and working well. That's the whole point of what we've discussed now. Artificial lenses work extremely well, but not as well as your normal lens. That's why sometimes, not always, but sometimes people with artificial lenses, when the cataract's been removed, need glasses. There's another question. Can you see pupillary mechanism with your own naked eyes? It is happening in your own naked eye. So yes, you will feel it. And that is sometimes when you go out from a dark room into the sun or from outside to inside. You can actually feel something happening in your eye. It's the muscles in the retina contracting and relaxing. Now, Colin has said about the white paper. Let's have a look. And with that, we're going to go over to our next aspect. There is your iris with a hole in the middle, which is the pupil. There are radial muscles in the iris. There are also circular muscles. Now, if the radial muscles contract, what happens? The radial muscles are then shorter. They become shorter, so the pupil enlarges. So the bigger pupil is because of the radial muscles contracting. The smaller pupil, what if the circular muscle contracts, as Colin has shown? You will find a smaller pupil. The iris has both of these muscles, but they don't contract at the same time. So to open, then the ciliary muscle is relaxed. To close, then the radial muscle is relaxed. And the function is simply to control the amount of light entering the eye to protect the retina against too much light, and in other words, against damage. And in darkness, to help you to allow maximum amount of light into the eye. The type of question where you must know that you must write about pupillary mechanism is walking out of a room into the light. I remember in one year there was a question about this guy spending some time in a cave and now he's walking out into the veld again. Or coming from light inside. Or the light is switched off in the room, what happens? Or the light is switched on. Anything about differences in light.
And don't forget about data response type of questions where they can give you a graph and then they can show you the size of the pupil at distance, or a lamp that at different distances away from the eye, which means there you can see down remember what Lorena said earlier on about distance, far and nearsightedness, but here we're talking about light and dark, or dim light and bright light. And remember then, the larger the pupil, the darker the room.
Right. Then we're sorry that we have to rush through these things, but we've still got a lot to do and our time is running out already. Then we're going to look at hearing in balance, if we can have the slide. And we're not going to go into the structure of the eye, of the ear. This is for you to know the different parts and to know where everything is, what the functions are. You have to make sure that you know.
Yeah.
Colin, maybe just one or two things here.
Yeah, just maybe quickly to show you that it's color coded to show you the outer ear, the middle ear in pink, and the inner ear in blue. Remember, the outer ear and the middle ear is filled with air, and the inner ear is filled with a fluid. And it is important when we come to the functioning of the ear. Right. Here we can look at the process of hearing, because that is one of the functions that you know, should know. And I think it's one of the more important ones that you have to know. First of all, just quickly, it's an air wave that hits against the auricle or the pinna, and then it is, you can see it goes through the auditory canal, and it hits against the eardrum. Then the eardrum starts vibrating, and you see the air wave is turned into vibration. And then when it hits through the three ossicles, through the oval window, it enters the cochlea, and then it enters the fluid. So the vibration is then converted into a fluid wave, and then after it has gone through this, the auditory nerve, you see, it is then turned into a nerve impulse. But let's look at that.
Yeah, I think it's actually a very good idea, sort of the whole way that you've said that. Okay, and here's step by step. The pinna traps the sound wave. There you can see number one. It's directed, so it's also about the function of the various parts, directed into the auditory canal. The tympanum or the eardrum starts to vibrate. It concentrates the ear wave, and with the ossicles, amplifies this ear wave up to 20 times. So the three auditory ossicles, the hammer, the anvil, and the stirrup, vibrate, and they cause the oval window to vibrate. And those vibrations are transferred to the endolymph in the cochlea. Now, inside the cochlea, there is a structure containing nerves called the organ of Corti. And the organ of Corti is where the stimulus, the wave in the fluid, is transferred, or shall we say, changed into a nerve impulse. And there's the auditory nerve. It takes the message then to the cerebrum to be interpreted, and in the form of sound. Now, just as with the eye, there are many reasons why a person can't hear. There are many reasons why a person can't see. So we can't go into reasons for deafness now. There are a myriad reasons. Some of them structural, with eye structures or with ear structures, some of them nerves. We suggest that you go and read, because we get many questions now about people wanting to know. How fast do you hear? Well, try hearing making a sound and picking up. Sound through air travels at about 340 kilometers per hour. So it is quite fast. So you hear almost immediately.
Yeah. Maybe just a suggestion for them is to draw a flow chart of that path of sound waves from the moment it hits the pinna until the sensation of hearing is maybe...
And you can get a picture like this, and the one on the slide, where they can ask you different parts and the function. And just one thing that we don't have here now, because hasn't got anything to do with hearing, is the eustachian tube that equalizes pressure on both sides of the tympanum and drains any fluid that might be there because of a hay fever or a cold or the flu. But you have to know the functions of these structures and what their names are. And then also, as Colin has said, a flow chart that will illustrate or that will explain the whole process of hearing.